So now we move on to the chemical properties of the HCl acid. We had gone through the preparation of the hydrochloric acid. Now we go for the chemical properties of hydrochloric acid. Now, so you will find that this particular part you will find it quite easily done because we had understood what are acids. So you can see first of all, hydrochloric acid as a dilute acid. So we will be seeing that all the properties of HCl which we are going to see first will be for dilute hydrochloric acid. Now we'll always find that there is a difference between the properties of an acid when it is dilute and the properties of acid when they are concentrated. So dilute acids normally behave like a general acid, so they will be having all the properties of a normal acid. So you'll always find that the general properties like neutralization, reaction with the metals, carbonates के साथ में, bicarbonates के साथ में जो reactions होते हैं, they all normally takes place with the help with the dilute acids. Concentrated acids, they behave a bit differently. So let's see one by one. Dilute hydrochloric acid is monobasic and exhibits acidic nature. So that's the thing, it is exhibiting acidic nature. Monobasic because HCl means monobasic क्या था? When it is able to neutralize only one OH molecule. Okay, that's why only OH radical. That's why क्योंकि उसके पास कितने H है? HCl is only one H. So it is monobasic. So monobasic nature, HCl dissociates in aqueous solution, that is H plus one H plus per molecule of acid. So we know that HCl is going to be, if I dissociate it, it will be H plus plus Cl minus. So only one H, HCl is going to become H plus and Cl minus, wherein H plus will be coming from the H plus plus, and this H plus with H2O is going to give me H3O. So this is what exactly is going to happen when this acid is going to be formed. Acidic nature, the presence of H plus, that is H hydrogen ion in HCl imparts acidic properties to an aqueous solution of hydrochloric acid. So aqueous solution of hydrochloric acid is going to give an acidic property because of the presence of H3O. इसीलिए HCl gas is neutral. It is not going to be acidic in nature. It will be neutral. Whereas the acid, when it comes, but of course what happens is HCl gas, when you are testing with the moist litmus paper, तो moisture उधर आ गया, इसीलिए acidic nature आता है, but otherwise they are not that acidic. Right. So a solution of hydrogen chloride in water being polar solvent, ionizes the HCl polar covalent molecule and dissociates into free ions. The aqueous solution of HCl shows acidic property and is an electrolyte. HCl gas is hence a covalent compound which behaves like an ionic compound in aqueous solution. So yeah, in an aqueous solution it behaves like an ionic compound, formation of H plus and Cl. Actually क्या है? Covalent compound. There is sharing of electrons. But as soon as it comes in contact with water, then what happens? H3O plus Cl minus. H3O plus Cl minus. क्या बनेगा? It is going to give you a ionic compound. So acidic hydrochloric acid will be ionic in nature. A solution of hydrogen chloride in organic solvents, for example toluene not being a polar solvent does not dissociate HCl into free ions, hence the solution of HCl in toluene does not exhibit acidic properties and is a non-electrolyte. So this is just to make you understand that HCl by itself is not acidic. If it would have been acidic by itself, then when you dissolve it in toluene also at that time, which is an inorganic compound, organic compound, then also it should give you the acidic property, but it doesn't give you acidic property with toluene. So it makes us prove that HCl by itself, the HCl gas by itself is not acidic in nature. Now we see the typical properties of HCl. We know typical properties क्या होते हैं? Acid plus active metal will give you the salt plus chloride plus water plus hydrogen. Acid plus base will be salt plus water, only that neutralization. Acid plus carbonate or bicarbonate will give you salt plus water plus carbon dioxide. Acid plus sulfide or bisulfide will give you salt plus water plus sulfur dioxide. And acid plus sulfide will give you salt plus hydrogen sulfide. So these are the 5 reactions which are standard for the acids. So we are going to see the one by one, these ones and examples of each. The first one is with active metals. So first reaction is with active metals. So first is active metals. We'll take one example of each. So we take the active metal Mg. So Mg plus HCl. This is going to be dilute. So dilute HCl over here is going to give me the reaction as MgCl2 plus H2. So that's MgCl2 plus H2 gas will be revolved. This is the same thing can be for Fe or Zn also. The same reactions. This proves that HCl is going to be containing, this also proves that HCl contains hydrogen in it because hydrogen gas is given out. The second equation is for neutralization. So with a base, so when it reacts with a base, so we have over here like CuO plus HCl, dilute again. We are taking dilute, all are dilute, so all dilute acids. So we are having dilute HCl as the reaction, so I need not write it again and again. Will give you CuCl2 plus H2O. So that is salt plus water. It is going to be base plus acid giving you salt plus water. So you're getting a 2 over here. You also will be able to got 2 over, right? The third one is with bicarbonate. So we have got a bicarbonate, metallic carbonate, bicarbonate. So metallic bicarbonate. So when I take a metallic bicarbonate, what is going to happen? Like we take NaHCO3 plus HCl will give me, again it will be giving me as the option as NaCl. Na will go with the Cl, so it will be NaCl, salt plus water plus CO2. This is the reaction. Bicarbonate is giving me salt plus water plus carbon dioxide. Okay, general property of a gas, of a acid. Sorry. The next is sulfide. So fourth one will be, okay, I missed out something. Yeah, bicarbonate. I missed out carbonate over here. So fourth one we can take as metallic carbonate. The metallic carbonate we can see, we can take the example of Na2CO3. Yeah, okay, we Na2CO3 will be HCl, will give me NaCl plus H2O plus CO2. Same reaction. Fifth one will be metallic sulfides. Okay, it will be metallic sulfide. Sulfide. We are taking the example over here of again Na2SO3 plus HCl will give me NaCl plus H2O plus SO2. Right? Sixth one will be metallic bisulfide. Bisulfide will be NaHSO3 plus HCl will give me NaCl plus H2O plus SO2. Right? So same reactions in both the cases. Products. So same, not reactants, but products are the same. Okay. We now move on to sulfides. Okay, so we have over here the next one. It's very simple now. There is nothing important, but nothing difficult. It's important. It's very important, in fact. So the next one is, seventh one is with sulfides. So it will be, they given the example of again Na2S, or we are ending FeS now. FeS plus HCl will give me FeCl2 plus H2S. Now, very important. What is the observation over here? Now, in case of H2S, whenever you get observation and whenever you get H2S as the gas, one observation will be that it is going to give you a rotten egg smell. Okay, the odor, rotten egg smell for H2S is an important thing. Right, there are also some color changes in case of a copper sulfide. If you are taking copper sulfide, is black in color. When it becomes copper chloride, it becomes blue in color. The next is silver nitrate. The next eighth one is reaction with silver nitrate. So this is a special reaction. Okay, this is something which is unique in nature. That's why it becomes a very good example of identification of HCl also. So if I want to identify whether a particular acid given to me in a bottle is HCl or not, I can use this as identification. That is AgNO3 plus HCl is going to give me AgCl2 plus HNO3. Now this AgCl over here, sorry, AgCl is a white PPT, white precipitate. So the presence of this white precipitate in the reaction tells me that this is a chloride acid, that is a chloric acid. If I use sulfuric acid, it's going to be AgSO4, and AgSO4 is not soluble, and it's soluble, it's not going to give me a white PPT. Hence, I can easily identify whether the acid given to me is hydrogen chloride or sulfuric acid. Okay. Similarly, I can have another compound which can be used for such a thing, and that is going to be lead nitrate. So lead nitrate also gives me the same kind of reaction, that lead nitrate PbNO3 twice plus HCl is going to give me PbCl2 plus HNO3. This again is a precipitate of white color. So it gives me a white color precipitate again when I am taking lead nitrate. So lead nitrate will be insoluble in cold water. Yes, hot water में soluble है. So वो फिर से solubility chart. I am telling you, that is one of the biggest reasons I always take acid basis salts first and then come to these chapters, because here getting the knowledge over here, it's automatic. अरे हाँ chlorides are insoluble, ये अरे hot में soluble, low में not soluble, ये सब दिमाग में घुसाना पड़ता है, तो ये याद रखना पड़ेगा. तो अगर इसके बाद में जब भी हम लोग एसिड बेस सॉल्व्स करते हैं तो it becomes ये पूरा rectifying हो जाएगा. यहाँ पे क्या है, you are able to understand it better. So that's why it's better to always take acid base salts chapter first and then these chapters. That is what they are given in the textbook also that way. And the last reaction is with a very unique material, and that is thiosulfate. Thiosulfate. So thiosulfate is given as Na2S2O7. Okay, S2O3. Sorry, Na2S2O3, which is going to be reacting with HCl to give me the same thing, and it will be giving me NaCl plus SO2 plus H2O also. But apart from that, it gives me an S. Sulfide bisulfides जो है उससे इसका difference कितना है? That it is going to give me 1 sulfur extra. In this one, there was only this 3 products, whereas here there are 4 products. So thiosulfate is Na2S2O3 plus HCl, giving me NaCl plus SO2 plus S plus H2O. So that is how we are getting the reaction with thiosulfate. Now we see this was dilute hydrochloric acid. Now we come to concentrated hydrochloric acid. So we have got certain kind of reactions which are typical in case of a concentrated acid of HCl. So concentrated HCl we can identify, or we can say the main thing is that concentrated hydrochloric acid, concentrated HCl is a oxidizing agent. What do you mean by oxidizing agent? The one which is going to help in oxidizing means one which is going to help in adding hydrogen, adding oxygen or removing hydrogen. So you can imagine अभी क्या हो सकता है, इसके अंदर हम लोग क्या करेंगे? We are going to remove oxygen. So if I take a metallic oxide, okay, if I take a metallic oxide and I react with concentrated HCl, metallic oxide, when I react with concentrated, now I know that concentrated HCl is a oxidizing agent. So what is going to happen? It is going to remove the oxygen. So sorry, concentrated HCl when reacts with the oxidizing agent, it is going to be it's a reducing agent. Sorry, absolutely sorry for this thing. For the confusion, but yeah, it's when it reacts with the oxidizing agent, when HCl it is going to be reacting. So reacting with an oxidizing agent. So when concentrated HCl reacts with the oxidizing agent, with any oxidizing agent, so oxidizing agent are like MnO2 is an oxidizing agent, then PbO2 is an oxidizing agent, then Pb3O4, KMnO4, yeah, we can take KMnO4, potassium permanganate, K2Cr2O7. All these are oxidizing agents. Now these oxidizing agents, when they react with HCl, they are going to give me the reaction wherein we'll be getting me MnCl2. So first thing is that it is going to give me salt plus water plus chlorine gas. Now this is something unique. This acid, it's a base. This is an acid. Base plus acid giving me salt plus water. But here, being concentrated, this is concentrated, hence it is going to give me one more additional thing, and that is chlorine gas, which is given out. So chlorine gas is going to be evolved in this case. Here also the same thing, HCl is going to give me PbCl2 plus H2O plus Cl2. So this is one equation over here. You need to balance this thing by putting a 4 over here, 4 over here, that is 2H2O and 2H2O. Yeah, this one, the reactions are going to be slightly different. So K and M both are there. That's why it will be HCl over here. There will be 16 over here. And this is going to give me 2 KCl plus 2 MnCl2 plus 8 H2O plus 5 Cl2. So this is a reaction wherein if you don't learn the reaction properly with the balancing, then balancing itself is going to take a long time. So better to learn this thing with the balancing. So we can always remember as 216 2285. So that is the balancing, 216 2285. Okay, it's the easy number, 216 2285. So that is the reaction for here. Similarly over here also it is going to be this plus 14 HCl give me 2 KCl plus 2 CrCl3 plus H2O, 7 H2O plus Cl2. So Cl2 is 3 over here. So yeah, you again for K2Cr2 said 114 2273. So 216 2285 and 114 2273. That is the reactions. Or you can see these are the balancing for the equations. So we see over here that oxidizing agent plus concentrated hydrochloric acid giving salt plus water plus chlorine gas. So the chlorine gas, which is evolved by this particular concentrated HCl, is the property which is something unique about concentrated HCl. Oxidizing agent, for example, HNO3, oxidized concentrated HCl, liberating nascent chlorine, which is nothing but the part of aqua regia. Aqua regia is a very important material which can easily even dissolve form salts of gold and platinum. Gold and platinum normally they don't react with anything, but they are going to react with aqua regia because aqua regia gives you the nascent chlorine, and the nascent chlorine is helping to get attached to the platinum or gold to give you the reaction. So these reactions over here are given that nitric acid plus hydrochloric acid will give you salt plus water plus chlorine, and this nascent chlorine is going to react with gold or platinum to give you gold chloride or platinum chloride. Hence aqua regia dissolves noble metals for gold, for example gold and platinum, which are insoluble in all other acids. So yeah, HCl plus HNO3 will give you nascent chlorine. So these reactions are not important much, but yeah, you can just note it that it is by aqua regia is the ratio of 1 part of nitric acid and 3 parts of hydrochloric acid. 3 parts hydrochloric acid, 1 part nitric acid, when combined together it gives you aqua regia, which gives you nascent chlorine. The nascent chlorine can react with the gold or platinum to give you gold chloride or platinum chloride. Now we move to the next part, that is the test for hydrochloric acid. Test. First test, very simple, glass rod dipped in ammonia. So yeah, a glass rod dipped in ammonium solution, that is NH4OH, brought near vapors of hydrochloric acid. So NH3 plus HCl will give you NH4Cl. So yes, first thing is If I want to test whether the acid which is being used is HCl or not, I can just dip a glass rod in ammonium hydroxide and bring it near HCl, the acid. If it gives me dense white fumes, yes, it is hydrochloric acid. The second is when reacting with when reacting with silver nitrate, dilute HCl will give you white color precipitate. I told you this thing. We just erase that thing, but yes, it is AgNO3 nitrates. Okay, silver nitrate will give what? Silver nitrate with HCl will give me silver chloride. Silver chloride is insoluble, giving me a white precipitate. Sorry, white PPT, white precipitate. So the white precipitate formed is giving you the idea that this is a HCl acid. So yeah, curdy white precipitate of silver chloride obtained when AgNO3 plus HCl giving me AgCl plus HNO3. The white precipitate of silver chloride AgL is soluble in excess of NH4OH and insoluble in dilute HNO3 and cold water. AgCl plus 2NH4OH gives you AgNH3 twice Cl plus H2O. So this diamine silver chloride is going to be given out when AgCl is going to react with NH4OH. Just for your extra knowledge. AgNO3 added to HCl also distinguishes HCl from dilute HNO3. So yes, I can easily distinguish. So if I am told that I got two bottles, one of HCl and one of HNO3, how do I identify that which one is HCl and which is HNO3? I just need to take silver nitrate. If I take some silver nitrate and then add to that some acid, अगर मुझे white PPT मिला तो it is hydrochloric acid. अगर white PPT नहीं मिला तो it is a nitric acid, because AgNO3 which is going to be formed by nitric acid is soluble. So that was the second identification using silver nitrate, and the last one is identification of concentrated hydrochloric acid by the use of manganese oxide. Manganese oxide is MnO2. This manganese oxide is going to give me chlorine gas. अगर मुझे yellowish gas अगर मिलता है तो उसका मतलब है the acid which I have used over here is hydrochloric acid. So greenish yellow gas of chlorine is evolved. So MnO2 plus HCl concentrated gives you MnCl2 plus H2O plus Cl2. So reaction proves that HCl contains chlorine. So this is the test, the three tests which are possible to identify the HCl acid. The uses of hydrochloric acid, industries mein it is used for making dyes, drugs, paints, silver chloride, glucose from starch. In the following industries like tanning industry and soldering industry. Okay, that is for industrial uses. Extraction of glue from bones. So to make glue from the bones, you need this particular kind of acid. So it dissolves the calcium phosphate present in the bones, and what you get will be the lump which will be used for gum. So dissolve the calcium phosphate present in the bones. In pickling of metals before galvanizing, pickling means cleaning completely, thorough cleaning of the acid so that it becomes reactive to the galvanizing. So galvanizing sticks to that thing properly. इसको pickling बोलते हैं. So that is hydrochloric acid dissolves the metallic oxides, coating impurities on the surface of metal, thereby cleaning the surface. So yeah, cleaning process is pickling. Preparation of aqua regia. Yes, we just understood that we are taking one part of nitric acid and 3 parts of hydrochloric acid. So nitric acid and concentrated in the ratio 1:3 by volume. So it dissolves noble metals like Au and Pt, gold and silver, gold and platinum, and that is the reason we use hydrochloric acid for aqua regia, preparation of aqua regia. So these were the different uses of hydrochloric acid, and that also ends the chapter hydrochloric acid completely. So this was the chapter. We have done this in 3 parts, video 1, 2 and 3. Very easy chapter as such now, because the understanding is very clear about the acids. So main thing, the chemical equations over here are very important to be learned, but most of the chemical equations which are there are standard chemical equations. We know very well that all the acids are going to behave in the same manner. So except for the preparation part, you need to learn properly the equation. You need to learn the equations of those which are not a part and parcel of the standard equations of the acid. So see, active metals, you know, hydrogen gas is going to be given out. Carbonates मालूम है, bisulfates सब मालूम है. Main thing are those one about the AgNO3 and also that one will be the one which will be you need to remember properly about the silver nitrate, lead nitrate, and then thiosulfate. Yeah, and finally these one, the reaction with oxides, oxidizing agents. So reaction with oxidizing agent will be something which is new, which you need to learn. So otherwise all the equations are such that you can easily frame them because you already know that they are from the basic properties of acids, that how the acid reacts with any particular substance. Okay, so this was the end of the first chapter of compounds, study of compounds, that is HCl. Thank you.